Welcome to the 5G Guys podcast, the premier resource for industry insiders and newcomers alike to explore anything and everything wireless telecommunication. We discuss, explain, and explore all things wireless technology. So let's dive right in. Welcome your host, Dan McVaugh and Wayne Smith.
What's up, guys? Thanks for joining us again. Before we get started, as always, want to make sure you hit the subscribe button if you like what you're hearing. Tell your friends, give us some stars, and definitely go to 5gguys.com to interface with us, ask questions, check out our blog, and all other things 5G. So as we get started, I'd like to introduce our guest today, Patrick Perini. Patrick holds a PhD in electrical engineering. He began his career working for NASA's Jet Propulsion Lab, developing space shuttle imaging radar. After that is where he and I first met when he moved on to US West Wireless and worked in their advanced technologies group. Over there, he led several research teams in wireless communications. Those efforts included research around smart antennas for 1G and 2G networks, RF propagation modeling, and wireless data technologies. In 2003, he formed his own consulting company, EFR Inc. For 17 years, he consulted to the engineering service group at Qualcomm, developing training courses in 2G, 3G, 4G, and 5G technologies. He delivered training to professionals throughout the wireless industry. Today, he resides in Hawaii, where he works with Hawaiian Telecom, deploying fiber to the premise, offering voice, TV, and internet services. So, Patrick, thanks for joining us. Great to have you.
Great to be here. Thanks for having me.
So this episode, we thought we'd dive a little bit into the comparisons of 1G, 2G, all the way through 4G. I know you guys probably get this a lot when people find out I work in the industry. That's probably the most common question I get. So we thought we'd dive into that a little bit today. Maybe I'll explain the way that I try to explain it to people in layman's terms. And then, Patrick, you can dive in as the expert and kind of tell us where I'm going wrong with that explanation, where it works, and maybe kind of fill in some of the gaps for us. Sound good?
Great. Yeah, sure.
So the analogy that I came up with over the years was to compare the different generations of wireless technology using the analogy of cars and roads, because really it's about not just the technology, but it's about the spectrum or the radio waves that the technology works on, because the two go hand in hand. And so where that analogy comes in for me is the technology is like the car, and then the spectrum or the airwaves that technology is working on would be like the road that the car is on. So in the early 90s and in the United States, when we were working with 1G, I would analogize that to Model T would be the technology we were working with. And it was riding on, a dirt 2-lane road. There was a small amount of spectrum the FCC had allocated. And so, we were humming along, everybody with the same cars that were kind of sharing that dirt road. And when we got to the mid 90s, and the FCC allocated a bunch more spectrum, we also advanced to 2G technologies. And I would equate that to, we now had a bunch of Ford and Chevy and Chrysler, Plymouths, and basic run-of-the-mill cars. They were better than the Model T. And we had 2-lane paved highways. So now we could do more with the cars. The cars were faster, they're more maneuverable, and they also had more room, more space to go a little faster, do a few more things. And then as we progress into 3G, we're now progressing into, say, a better car. I wouldn't call it quite a Porsche, but, a Mazda RX-7, let's say, has more maneuverability. It's faster, 0 to 60 is better. And we now have interstate highways with, 3-4 lanes each direction, because we now have even more spectrum to use that on. So, as we progress in technology, we're progressing with the regulatory and the available spectrum. And so the two are going hand in hand, and we're able to support more cars, i.e. more phones, and the technology is getting better. As we progress to 4G, my analogy would be, now we're all driving Porsches, Maseratis, and we've got, 6-lane interstate highways. So we have lots of lanes, can support a lot of cars that can do a lot of stuff, but we can still have a Model T and a Plymouth on that road. We can still have 2G phones, but we have better spectrum. So they're coexisting. Now, as we look forward to 5G, I would equate that to, we're talking about everyone's driving McLarens, and we've got 30-lane superhighways, something that we're never used to existing with some of the high millimeter wave spectrum and things that 5G can now work on. And so when the two go hand in hand, we put that Maserati on the millimeter wave spectrum, the 60-lane highway. It can do some amazing things. However, if we don't have that highway, i.e., T-Mobile deployed 5G on a low band spectrum, which is equivalent to like the 2G, 3G spectrum that we had back in the day. That Maserati can't do a lot on a 2-lane paved highway. You can't really open it up. So that's kind of the analogy I've come up with over the years. Does that make sense to you? Where does that analogy break down? Where does it work? What are your thoughts, Patrick?
Well, I think it's a really good analogy. I think the analogy of the phone to the cars is good because you're seeing the progression of the technology. Each phone generation of phones had certain improvements with them, just like the cars generationally have improved. And I think the analogy of the road is also a useful one in the sense that in the olden days, we didn't have a lot of good roads or a lot of spectrum, so we didn't have a lot of bandwidth. We couldn't go very fast on those old roads with our phones, per se. And then as time went on, we added more radio spectrum to the technology, which allowed us to open up the roads more, use our phones for more things as the phone speed increased. And then I think it's interesting if you think about maybe where the analogy, I don't know if it breaks down or you maybe extend the analogy in how you think about it. For example, we have pretty much dirt roads across our country, and we have paved roads across our country. And so we have spectrum covering the entire country that can do basically 1G, 2G, even 3G, now 4G type technology. And what's interesting is we get 5G, the superhighway concept where, okay, I have this phone that can do essentially fiber speeds to the phone, gigabit Ethernet speeds, millisecond latencies. That's the analogy of your 20-lane superhighway. But we can't really build that highway anywhere but where? Probably the big cities. It's the only place it's going to make sense. And that new technology, 5G, it's really expensive to build that wide highway. And every mile of it you build costs you a lot of money to maintain and keep up. And so it's not going to be very easy to build this super 5G millimeter wave highway in central Wyoming, for example. It's probably not going to happen in the suburbs of a lot of major cities even for a long, long time, just because we have to put one of those millimeter wave cell sites every couple hundred meters or so. And so that becomes problematic to try and cover the entire country with that technology. And so not everybody's going to drive a McLaren or use their 5G phone like it's a really souped up phone, unless they maybe encounter that super lane highway when they travel to the airport of a major city. And so what I find interesting about the upgrade of these technologies from 1G to 2G to 3G to 4G is most people don't ask me the question, what's 5G? Should I get 5G or is it better than 4G? You do get that question, but it's more often now to me geared toward, should I buy the new iPhone 13? They're more focused on what the phone can do than I think the generation of the technology. Once we made that generational shift, I would try and find something in your analogy, Dan, that equates to when the iPhone was introduced in 2008, because that changed everything as to how we use the phone. It's almost like the first iPhone was like the first Tesla, the first electric car that really now is transforming how the phones are used and how they operate,
My head was going exactly there. Tesla, I think, is a great analogy. People want to learn about and get the next Tesla. They don't necessarily know what the next Tesla does. They just want to get in on it. And that's I agree. That's a good analogy to add to that.
I think jumping in a little bit for me there is that I've had every evolution of the Tesla, and believe it or not, everyone has gotten a little better, a little faster, a little safer. And now this current one, the 2020, is fully autonomous driving. And it'll come to you. It does things that the other versions just wasn't capable of doing, and it does it super easy at a less cost, though, I would say too. They're getting cheaper than they were.
That's a great teaser for a future episode, Wayne. We'll be getting into some of the ways that wireless is helping stuff like autonomous vehicles work. So that's a good. Let's digress a little bit back to let's talk about what what was the foundation of 1G in terms of what was the technology in the Model T car back then, Patrick? What was unique about 1G that changed later when we got to the later generations?
So what we like to teach about 1G was that 1G was the first time we introduced the concept of voice mobility. Hey, I have a phone that doesn't have a cord. Essentially, that was the big deal about a mobile phone, and trying to make that phone miniature enough so that you could carry it, right? Because the first mobile phones, they had to put the radio in the trunk of a car. And so it took us a while just to get the electronics miniaturized. It was using old FM analog modulation techniques that we learned way back in the 80s in college when I was in school. There was no digitized voice yet. It was an old telephone network, or it was, I should say, a new concept, a cell phone attached to a telephone network via old telephone circuitry. And so that in of itself, I think, was, revolutionary. It became very popular. I remember getting my first analog cell phone in the early 90s, and the technology was introduced in the 80s. And it was just, wow, you have a cell phone. You had to be like a hotshot to have a cell phone back then. And then I think what happened with 2G, when you and I met at US West Wireless and we were doing all the deployment for second generation, we digitized the phones and we essentially made something that was, you need $1,500, $2,000 to buy a cell phone and own one, right? To something that we would start to figure out how to subsidize, bring the cost of the handset down to a few $100s, and get everyday people starting to buy these phones. And the digitization, I think, of the electronics helps drive the cost down. That was a big part of it. And then getting the talk time up.
And the size, right? The phones got smaller.
Yeah,
right?
the size of the phones got smaller. And we also introduced what was interesting, but not very well, done at that time, was we introduced the concept in 2G of data mobility. All of a sudden it was like, okay, you could do a text message kind of concept. Send a small piece of data, albeit at a very slow data rate, right? A few kilobits per second is all we could do back then. But still, it was the first time with both, I think it was called GSM, right, and CDMA technology, where we started to play around with, hey, I'm going to send a little data. And that then led us to, of course, 3G.
Right. And one more big difference I recall before we jump onto 3G was when we were in the analog 1G days. Of course, we didn't call it 1G back then, right? We didn't start calling it 1G till we got to around 3G, but was the power of the phone itself, right? The phones in the analog 1G days, they were 3 watts or 1 watt portables. So they used a lot of power. So they had to have big batteries, right?
Right.
They got hot. You could feel them get hot in your hand while you're talking. When we moved to 2G and we moved to digital, that also enabled us to go lower power, right?
Right. And that extended the usage of the phone a long time, right? You didn't have to recharge the phone twice or 3 times in a day.
Right. So starting with 2G, the output power of a phone was like 250 milliwatts, a quarter of a watt. So it was significantly less power coming out of that phone at that point.
Yes.
Yeah. So, okay. So we get into 2G, we're now digital. We're starting to do a little bit of data. Then what happened with 3G? What were the big changes that came with that?
Well, I think with 3G, they started to think about, how do I build radio technology that supports voice and data simultaneously? And how can I scale now that data usage with more bandwidth? Because I can't do a lot on a data call, if you will, if I'm only supporting a few kilobits per second. And so the idea, I think, with 3G was, how do we figure out how to start driving the data rates beyond kilobits per second? And so 3G technology was the first wireless phone technology to get us megabit per second speeds to the phone. And then that makes the phone now capable of doing more things like web browsing and using the phone in a way we never had before. And of course, the phones weren't capable of web browsing because they didn't have screens in the early days of 3G. So I feel like 3G was sort of this bridge between taking the phone as a voice device to taking it to a full data device, which is kind of what happened in 4G. And so 3G is the bridge between that. And as a result, the standard was, I felt, a little kludgy. It was trying to be everything. It was trying to be a voice phone. It was trying to be a data phone. And we had a lot of overhead to set up the calls and manage the data, because we had to, inside the network, essentially build both a voice network connection from the base station back into the network, as well as a data connection, and keep track of, is it voice or is it data, at a place we call it the base station controller. So that created a lot of overhead, and it was not the most efficient way to do data, but we had to sort of make this transition of the device becoming predominantly a voice device, which our generation, the older folks, tend to use, whereas the younger kids, my nephews and nieces, as soon as they got cell phones, they weren't calling anybody. They were just texting all the time. And so the devices and the utilization of the devices started to become more data-driven. And then I really think that the interface to the user, the smartphone, the first iPhone, really it completely changed everything in how we use the phones. And it changed the traffic on the network. So it was predominantly, before the iPhone, voice traffic on that network. And we were concerned about capacity, is how many calls per cell can we support, and all this voice growth, to, wow, the voice traffic all of a sudden now is starting to plateau at the end of the 3G life cycle, and the data is starting to take off. And that's now kind of what we see right now. How often do we avoid calling each other right now? Nobody calls each other anymore. Only if you have to do you make the voice call. So we can see, when we traffic now on networks for the operators, right, all their voice capacity has pretty much hit some plateau, and it's the data growth that they're dealing with now.
Hey, real quick, a quick word of thanks to today's sponsor, Vertex Innovations. For over 17 years, Vertex has been building the nation's wireless and broadband networks. Providing project management, network engineering, and construction oversight are just some of the ways Vertex helps their clients. So if you're looking for more of a partner to help you with your wireless network designs, construction, implementation, or operations, reach out to Vertex. You can find them at vertex-us.com. That's VERTEX-us.com. Yeah, I almost feel like 3G is to 2G as DSL was to dial-up, right?
Yeah, that's a good one.
Yeah, I feel like, because that's what we're doing with dial-up. We were just using a voice circuit on the telephone plant to push some data bits through it, which is what we were doing in 2G as well. And it's really with 3G that we started creating a different pipe, like you described, for the data, like a DSL service was doing, or is doing still today. That's good. I think that helps explain a lot. I think the other thing that was going on, especially when we were in the middle of the 2G, 3G era, was every company worldwide had the opportunity to use a different standard, a different technology for their 2G technology. So you had Fords, you had GMs, you had Chryslers. As a consumer, if I had a phone from Sprint and I wanted to go to T-Mobile, I couldn't take that phone with me. It was a completely different technology platform. I had to get a new phone from T-Mobile, right? And so I think that kind of segues us into 4G. So maybe I'll let you kind of run with that, because that also is, not only was there a new technology, a huge technology jump with 4G, but we start moving towards more of a common standard almost worldwide at that point?
Yeah, so one of the things we teach a lot in the wireless technology evolution of 1G, 2G, 3G, 4G was the fact that we started with this sort of analog technology, this new technology in 1G, but when we went to 2G, you had to make a choice. You had to choose whether you wanted to go down this path that was based on GSM, that used a form of time division multiplexing of the radio channel, so the users shared time slots to make phone calls, versus Qualcomm's code division multiplexing scheme, where each user gets assigned a code in the radio channel and we divvy up the channel using codes. And so these two technologies sort of became competing technologies, and it almost became a religious war, if you will. You were either in the TDMA GSM camp and you thought that was the best stuff, or you were in the Qualcomm CDMA camp. And the Qualcomm technology was American homegrown, right? The GSM stuff really was standardized in Europe. And so kind of what happened over the years of 2G and 3G is these radio technologies became bifurcated into two standards that were evolving. And if you were on, T-Mobile, right, and AT&T, you used the UMTS GSM radio technology standards. And if you were on Sprint or Verizon, you used the American Qualcomm CDMA-based standards for 3G. So this created this sort of competition. And it also made, actually, if you think about it, the cost of deploying these technologies probably a bit more expensive, more so for the CDMA folks. Because if you look at these two technologies, the GSM technology became sort of a worldwide standard. Everybody deployed GSM. There were 4 billion or half a billion subs. And so there wasn't the economy of scale for CDMA. And there was only one company that made a workable chipset, Qualcomm. You had to pay for those licensing fees. And that made Qualcomm, some money, and they did very well. They were very successful as a corporation with that. But they also, didn't make a lot of friends in that regard a little bit, because everybody had to pay them that licensing fee. And so we had this sort of, two sets of standards competing. And I think what happened in 4G was that the big players, Verizon, Vodafone was in Europe, right? That's a GSM technology they were using, but they owned a large part of Verizon. And so I think when they got together and started thinking about, do we want to go forward into 4G with these two bifurcated standards, or does it make sense to use one standard? And so when Verizon decided, along with Vodafone, to go to LTE technology rather than try and standardize a version of 4G from Qualcomm, essentially, standardization processes in America, that really led to every other vendor or every other operator, in the world going towards long-term evolution as 4G. And we sort of converged onto the evolving technologies from GSM, UMTS, and now 4G LTE. That got everybody using the same technology. And that makes it a lot easier now for you to take your phone from one network to the other. Among other reasons, the operators are much better about unlocking the phones and allowing you to use these phones, particularly because now they're not subsidizing that phone price anymore, you'll notice. If you go to buy your phone today, you got to pay $1,000 for your fancy new phone. In the days of 2G, 3G in the United States, more so, there was a lot of phone subsidization going on. The iPhone 7 that I have still today that I'm using, I got Verizon to pay for it by subscribing to them for 2 years. But they don't do that too much anymore. So I think we have more choices. We pay a little bit more for our phones, but we also now have the freedom to move around from operator to operator. And I think also transformative in 4G was that we went to the phone network became completely a data network. So one of the interesting things about 1G, 2G, 3G is when you made a voice call, it was still a voice call connected to the old voice network. The old phone company, the public switch telephone network, used old TDM telco technology. Now, right, all the voice being carried by your new 4G phones, right, is voice over IP. It's all based on internet protocol. And so there's no more notion of having to build this sort of schizophrenic core network that we did in 3G, where half of IP and half of it's, voice TDM. Everything is now based on internet protocol. Your phone gets an IP address, and that IP address, we form essentially a tunnel between the base station all the way into the core network, so that you have now some form of quality control, whether it's best effort or some other form of quality control through that IP tunnel that we formed from your device to the network. And so that, I think, is what was really transformative about 4G, is now all the phones are essentially acting like internet protocol devices doing data. It's a data-centric device. It's no longer a cell phone, if you will.
Yeah. One question that I think I was told, Peter, was about the 4G, that we'll still have that technology for quite a long time here, that it's that good in the network that 4G will be around for another 10 years. Is that true? Is that a true statement, or is that just the life cycle of these types of technologies?
I feel that 4G will stick around for a long time. It's interesting that you mentioned the duration of these technologies, because they're now going to sunset the 3G technology. Most of the operators are going to retire the older CDMA and UMTS technologies that they were using for 3G this year or next year. I do believe that, yes, 4G was so transformative in the radio. We went from a completely different radio technology of CDMA-based in 3G to OFDMA-based, orthogonal frequency division multiplexing. And that radio technology is very, very good, very efficient at allocating bandwidth by virtue of how you design the spectrum or utilize the spectrum. And it's very easy to implement in the radio because we build essentially the radio channel in the frequency domain, if you will, and we transform it into the time domain. This makes it much easier to do all this fancy signal processing that we do with multiple antennas, what we call MIMO. This is much easier to do that way. So the radio technology is so good, really, that we did with 4G. When they went to 5G, they're essentially using the exact same radio. The only difference is that at 5G, they're scaling that technology so that it'll work not only at the radio frequencies we're used to for 4G, 1, 2, 3 gigahertz, radio frequencies, but we can scale it up to millimeter wave because I can't build that radio channel the same way at 1 to 2 gigahertz when I want to build it up at 28 gigahertz. I have to actually make the channel bandwidth wider, and I have to, these little subcarriers that I use in the radio channel, in LTE 4G, they're 15 kilohertz wide, each one of them. And we use a whole bunch of them, hundreds of them, to carry your data. So if I want to scale that up to 28 gigahertz or something for millimeter wave, that little subcarrier can't be 15 kilohertz anymore. I got to make it wider so that I can have a reasonable number of subcarriers for this much larger bandwidth so I can play my OFDMA tricks. So there's a lot of just what we did was scale the radio channel to be able to do what it does in 4G, to do it at higher frequencies when we want to with 5G. But it's essentially, if you look at 5G radio channel operating down at 1 or 2 gigahertz, like a 4G radio channel, it's exactly the same. The only difference might be the bandwidth that you're allowed to use, but the subcarrier spacing and everything is the same, and the overall architecture of the radio doesn't really change.
In fact, that's what T-Mobile's doing right now. They deployed 5G at 600 megahertz, which is a 4G spectrum that was allocated for 4G. So they're using 5G in a very narrow bandwidth relative to what 5G is designed to work at, right?
Yeah, exactly. And what's great about what they did is that they can now tell everybody, hey, we've got nationwide 5G because they used a low frequency band at 600 megahertz. Whereas AT&T and Verizon, because they didn't use any low band spectrum, they tried to go out and do millimeter wave 5G so they could claim, hey, I've got a gigabit to your phone. The problem is they only have 5G coverage in a couple of cities in downtown. That's it. So that's the trade-off of fast with millimeter wave. You're not going to be able to cover the country. And a large percentage, if you think about it, how many Verizon customers or AT&T customers are actually living in the coverage of a millimeter wave cell site? Not a lot of them, really, relative to their overall customer base. The other thing they notice is that the customers who have 5G coverage, it's interesting because of the nature of the millimeter wave, you get in and out of that coverage pretty quickly. And so you're not spending all your time on millimeter wave, even though you might have a 5G millimeter wave phone. Your phone spends a lot of time doing 4G stuff on 4G frequencies or 5G low band frequencies as to not utilize the millimeter wave all the time, in part because it just doesn't need it. Doesn't need that speed.
Right. So going back to the analogy, T-Mobile has enabled all of us that have a T-Mobile phone to drive our Maserati and all these country roads all over the middle of the United States, but there's still 2-lane dirt roads, and so I just can't open my Maserati up with T-Mobile right now.
Yeah.
At some point, when they get high band, or when Verizon and AT&T get high band, I will have my Maserati on that 50-lane superhighway, and I can open it up. Right.
Right. Exactly.
Are you meaning, Dan, make sure I understand, for our listeners, is that even though it's 5G, we're still connecting at 50 megabit speeds versus 100 megabit speeds? Is that what that means?
Well, it's higher than 50 for sure, but it's not anywhere close to the maximum throughputs that 5G offers. So my analogy is I can open up that Maserati to go 200 miles an hour, but on the way T-Mobile's deployed it right now at the narrow band, low band frequency, the road won't allow me to do that. I can really only open my Maserati up to 80 miles an hour, 100 miles an hour, analogous. So Patrick, confirm so I don't get it right. What kind of throughputs are we talking about that 4G promises, but it can actually only deliver right now with the way T-Mobile's deployed it?
Yeah, if you think about like what the advertised peak data rates were for LTE, it was like, oh, if you had a 20 megahertz channel with 4x4 MIMO and you're using the best modulation, you get 300 megabits per second, right? It's what people talked about. But the reality is that's the full capacity of the channel. Most people today, right, you speed test your phone on a 4G network, you might get what, 50 megabits per second, and you get latency of, 10, 20, 30, 40 milliseconds. And I think, to me, that's pretty good for a cell phone. That's basically what Wi-Fi was doing for you at your house. And so that's really good. And the way I see 5G maybe shaking out will be, maybe in a couple of years, once 5G is fully deployed, we got a lot of 5G phones out there, you speed test your phone, maybe now you're going to get 100, 200 megabit per second, speeds, and maybe the latency cut by a factor of 10. Now it's 2 to 3, 4 milliseconds instead of 20, 30, 40 milliseconds. And I think that latency going down is underestimated what it can do for you. It does a lot, actually, for applications I don't think we've seen yet. So the thing to recognize is that if I want to do some fancy AR, VR thing with a headset or something, right? I want to do some virtual reality, watch a baseball game or a football game VR through some cellular headset. If I want to watch something in real time and be able to feed that headset, I have to feed it with some pretty hefty data rates, let's say a couple hundred megabits per second at a certain latency. If you can get the latency down, like the latency goes from, say, 20 milliseconds to 2 milliseconds, then what will happen is the data refresh rate that you need to support that thing goes from 200 megabits per second to, say, 40 megabits per second. So getting that latency down allows you to run these applications at a lot more efficient bandwidth than you can today because the latency is still too high. And so these are things that I think will come in time. They're not part of what we use our phones for today. And they may not really be worked into the phones. They may be worked into other devices. People always ask me, what is the killer app for 5G or VR? And I find that a hard one to figure out. The one thing I started to think of was, how many people would be interested in going to the Super Bowl virtually? If the NFL could actually sell you for $200, basically here's your headset and you get to sit at the 50-yard line at the Super Bowl and watch it live. Would that kind of, reselling live sports is something I thought maybe people would sit in a room and do that with a headset for a couple hours. I've played around with Google Universe and my nephew's headsets and stuff, and I get bored with that stuff pretty quickly. But
Patrick, I think you're onto something. I think some of the large venue projects that we've built, we have deployed a 5G model into those sports stadiums.
Yeah.
Whether it's football or basketball, and what they're doing with it, I think they are trying to develop that kind of experience. And because that network is so tight, into that small geographical area, they can probably do the millimeter wave and have the higher speeds.
Exactly.
To offer that.
Yeah. I think the other thing it's good to recognize is that the advancement of these technologies, while they bring a lot of changes, a lot of features, a lot of new use cases for the users, the other thing that these advancing technologies have done for the industry is it's allowed the industry to be more efficient and the ability to handle the exploding capacity demands that have been put on these networks. So, when we're in the 1G days in the early 90s, like you said, only a few people had a phone. Like there was, tens of thousands of users, hundreds of thousands at the max in a population of 400 million. Today, with 4G and 5G, there's more phones than there are people in the United States. And then you add all the devices like parking meters and smart refrigerators and all that stuff to the mix. These networks have to have a massive amount of capacity. And so these technologies aren't just adding things that we as customers see as features, they're enabling these providers to support that huge demand in ways that they couldn't before, right?
Yeah, I mean, it amazes me all the things now that we're trying to connect through cellular and Wi-Fi technology. I can control the thermostat in my home remotely. I can open and close the garage door. It tells me if I left the garage door open at night. And so I think the Internet of Things is a huge area of growth for not just the cellular industry, but Wi-Fi and other industries as well. Just more and more of that connectivity of things rather than you and I with our devices. So that's really big stuff. And I think Wi-Fi and some of these other auxiliary wireless technologies also play a big role in it.
Well, listen, I think this has been a great overview. I hope this has helped our listeners understand kind of in a way how to break down and understand the big differences. I know for myself, every time I go through this analogy, I find tweaks in it, I find mistakes in it. And it's like every time I revisit it with folks like yourself, Patrick, I even continue to learn, and I continue to adapt my perspective on all of this. So this has been extremely helpful for me, and Wayne, I'm sure for you as well. I can't thank you enough for your time in joining us today. And if you'd be up for it, we'd love to have you for maybe a second episode where we can dive deeper into 4G and 5G. Are you up for that?
Sure, that'd be great.
Yeah, I think diving into these use cases and really going deeper into 5G would be a good future episode. So for listeners, please hit that subscribe button. Go to 5gguys.com. I'm sure you got a ton of questions. You can comment, ask us those questions, and we'll answer them. We'll hit them on future episodes. So with that, Patrick, thanks a ton for your participation. Any way that listeners can get in touch with you if they want to?
Yeah, LinkedIn under my name, Patrick Perini. P is in Patrick, Erini. Just look me up on LinkedIn, and I'm there.
Thanks, Patrick.
You bet. Good to see you, Wayne. Nice meeting you.
Until next time, guys. Thanks again.
Yeah, have a good one, guys. Aloha.
Thanks for listening to the 5G Guys. For more resources and to connect with Dan and Wayne, check out their website at 5gguys.com. If you enjoyed this episode, be sure to hit that follow button and share this episode with your friends and family.